Okay, so last time we talked about the two things that phytoplankton need to survive, right, which are light and nutrients. Those are the two limiting resources. So whenever you don't have a lot of light or a lot of nutrients, then that will limit the amount of phytoplankton that you can have. And phytoplankton, the light is located at the surface of the water. The nutrients are located deeper in the water. So they're in a little bit of a conundrum. They need those nutrients in order to survive. And so the only way that they can get those nutrients in order to be able to survive and to grow and reproduce is to have some sort of breakdown of that thermocline to allow the nutrients to come up. Okay? And that happens in wind. So when wind creates currents and creates like equatorial upwelling, you can get nutrients brought up to the surface. You can also get overturn. Okay, so remember when we talked about overturn? When you get more dense water on top of less dense water, and you get that dense water sinking down and the less dense water coming up. So you can get seasonal temperature changes, which will cause density mixing of the water, overturn. And then you can have upwelling. Okay, upwelling is the movement of the deep water to the surface. You can have wind upwelling like we talked about at the coast. So when the wind blows out to sea, it pushes that top surface layer of water out and pulls water up from the deep, bringing nutrients up. Or you can have geographic upwelling. Okay, that's where you have these big currents at the bottom of the sea moving along. And sometimes those big currents hit seamounts. And when those hit seamounts, that seamount forces the current to come up towards the surface, bringing nutrients with it. And so it brings nutrients up to the surface. Let me draw a picture of that for you. So here's our seafloor, here's our seamount, okay, and then here's the surface of the water. So your current, deep water current's moving along the bottom, and when it hits the seamount, it gets forced upwards, and so it brings nutrients up, breaks through this thermocline that way. All right? Okay, so it's called geographic upwelling. Okay, so you can have different kinds of what we call production. And production is just simply an increase in the number of individuals of the phytoplankton. Okay, increase in the number of individuals. So we have new production and regenerated production. Regenerated production occurs when the thermocline is present. So regenerated production just simply relies on the small amount of nutrients that you have above the thermocline. And that small amount of nutrients, because there's only a little bit, means that there will be small phytoplankton populations because there's only enough nutrients to support a small population. Okay, so regenerated production relies on nutrients that are already above the thermocline. New production occurs when the thermocline is absent. So if you have upwelling that's occurring, okay, or overturn that's occurring, you can get new production. Okay, and new production relies on nutrients that are brought up from the deep. And so because there's lots of nutrients in the deep, lots of nutrients means lots of phytoplankton, so you can have large population sizes with new production. Yeah, does that make sense? Okay. So the population sizes are large with new production. So when that thermocline breaks down and when you get new production, you get this thing that we call a bloom, okay, a phytoplankton bloom. Okay. Here's a picture to show you the difference between new and regenerated production. So regenerated production, remember this green line right here, that's the thermocline. Regenerated production relies on nutrients above. New production is when new nutrients come up from the bottom. So a bloom, okay, is a large increase in the phytoplankton population. Large increase in phytoplankton population. It will only occur when their thermocline is absent. Okay, and that means that you'll have lots of nutrients and lots of sunlight. So as long as you have lots of both of the limiting factors, you can have a bloom of phytoplankton. Blooms always begin as new production, and then they typically drop off once you have the thermocline forming and trapping the nutrients in the deep sea again. You have different bloom patterns depending on where you are on Earth. Okay, so the tropics, the poles, and the temperate regions will all have different blooming patterns of phytoplankton. And here's what we mean when we say the tropics and the temperate regions and the poles. So here's our world. Okay, let's redraw this. A whole new world, yeah. Okay, here's our world. It's a little lumpy, but it's okay. Okay, and so we use latitude and longitude in order to be able to describe where on Earth people are or where a location is. Okay, and so 0 degrees latitude is the equator. Okay, so latitude goes like north and south, and longitude goes east and west. So 0 degrees latitude is the equator. Okay, and then the very, very south pole would be 90 degrees south, and the very, very north pole is 90 degrees north. Okay, and so every line of latitude in between 0 and 90, so going south is going to be like 1 degree south, 2 degrees south, 3 degrees south, 4 degrees, so on and so forth, right? All the way down to 90. And then you've got 1 through 90 degrees north. Okay? So a couple of lines of latitude that you need to be familiar with are 30 degrees south, okay, and 30 degrees north. Okay? In between 30 degrees north and south, that's the region of the Earth we call the tropics. Okay? And then in between 30 and 60 degrees north and south, those are the regions that we call the temperate regions. Okay? And then anything south or north of 60, those are the poles. All right? Okay, so let's look at the bloom patterns in the tropics. And you will want to draw these pictures, because these pictures are those last 2 questions on your 5.2 homework. Okay, so I'll show you what you need to draw. But in the tropics, so light is always available because it's sunny, it's warm, it's the tropical regions. That's where everybody goes to vacation. There's not much of a difference between winter and summer, right? It's year-round, sunny and warm and lovely. So that means that light is always available, so light is not going to be the limiting factor for phytoplankton in the tropical regions. Okay? What is going to be the limiting factor is nutrients. Okay? And nutrients are always limiting because there's a permanent thermocline. So permanent thermocline in the tropics means nutrients never come up, which means you actually never get a bloom of phytoplankton in the tropics. Okay? So here's what you need to draw. Okay? So you need like this, okay? And this axis on your graph is going to be the population size of the phytoplankton. And then this is your bottom one, and you can divide that into your 4 seasons. Okay? Autumn and fall, winter, sorry. And then all you need for the tropics is like a straight line, because you have no bloom that occurs, so there's no large increase in population size, and the populations of phytoplankton remain low year-round. Okay, so it'll look something like this. See that? So spring, summer, fall, winter, straight line, population size, that's the tropics. Yeah? You see that? So no bloom of phytoplankton in the tropics. All right. Yes, they do. All right. Poles are a little different. So in the poles, you have nutrients always available because cold water holds more nutrients. You get more mixing of the water that occurs because of differences in density. And so you have nutrients always available. However, light is only available in the poles from late spring to early fall. Okay? Late spring to early fall. So that means where those 2 overlap, late spring to early fall, you get a huge summer bloom of phytoplankton. So you can draw this actually. same way that you would draw the other one, with your seasons along the bottom and your population size, and then you get a big increase in phytoplankton during the summer. You see that? So big increase. This phytoplankton bloom that occurs in the poles in the summer is actually why whales migrate to the poles. So every year whales migrate to the poles in order to be able to feed on the phytoplankton and zooplankton that are living there. So you get a big bloom of phytoplankton in the summer. And it's weird. It's weird that like blooms of these little teeny tiny microscopic plants drives the migrations of some of the biggest animals on Earth. So crazy. Okay. Temperate regions. That's where we are. Temperate regions have light that's available from mid-spring to mid-fall. Okay, and the nutrients are available from mid-fall to mid-spring. Okay, during the winter. So where do those two overlap? Fall and spring, right? So you would expect there to be a bloom in the spring and in the fall, right? And that's exactly what you see. So spring and fall. And then in temperate regions, you'll have a little bit of a different blooming pattern depending on if there's upwelling or not. So copy this down, and then I'm going to show you the picture. And the picture that I will draw for you, or that is there, is like 2 in 1. Okay, and that's actually the answer to your last 2 questions on your homework. Okay, this next drawing. All right. Can I switch the slide? Okay. So here's the deal. This red line right here, okay, this is what happens in the temperate regions without upwelling. Okay, so nutrients become available and light becomes available in the spring. Okay, and so you get this big bloom of phytoplankton in the spring. During the summer, you get a seasonal thermocline that forms, which traps some of the nutrients in the deep sea. So the bloom drops off. Still, the phytoplankton population still remains higher than it is in the winter, but it's less than the big bloom in the spring. Okay, and then again, once that thermocline breaks down and you get more nutrients available in the fall, you get a little bit of a bloom in the fall, and then it drops off for the winter. That's what happens in the temperate regions without upwelling. Okay, with upwelling, here's what happens. Okay, it's the blue line. So you get a big bloom in the spring because there's upwelling, a thermocline doesn't form, so you get nutrients available all summer. Population remains high all through the summer, and then when light drops off, so does the phytoplankton population. Does that make sense? Yes? No? Maybe so? Okay, so that's your 2 in 1 graph.